My dear students, today I am going to discuss the chapter of sets for class 11 maths. So it will be a continuation from my last two videos. So today's will be the third video. Okay. But before that, let me tell you a few things. So some students have asked how to subscribe to my channel. So these are the steps. First of all, you open the YouTube app. Then type search. In the search, you type Sai Maths Man. So this is the thing you have to type Sai Maths Man. And then you will see the word subscribe in red color. The word subscribe within a box in red color. So you tap that word. Tap the word subscribe, which is in red color. Then the word immediately turns colorless. The red color will go. It will turn colorless. That will mean that you have subscribed. So these are a few steps to subscribe, and please subscribe. Okay. All right. Now let us get back to that set for class 11. So as I told you before, today's video is the third video. Third video for the chapter of sets. So today I am going to discuss Venn diagrams. So I'll discuss today Venn diagrams. Venn diagrams. Okay. Now suppose this is a universal set. So a set of the digits 0, 1, 2, that way 7, 8, 9. Now this is the set of digits. This is the set of digits 0 to 9. This is the set of 10 digits in the decimal system, isn't it? And suppose this is a set 0, 2, 4, 6. All right. Now these two sets can be represented diagrammatically using a kind of diagram which is called Venn diagram. So this is the diagrammatic representation of these two sets. So a rectangle, the rectangle is the universal set. So this rectangle is the universal set. Now you see this set is a subset of this set. So 0, 2, 4, 6 all are present in this set. So this is a subset of this set. So that will be inside this rectangle. That means all these elements are included in U. All right. Now this circle includes which elements? 0, 2, 4, 6. So 0, 2, 4, 6. This is how the Venn diagram is drawn to represent this set. So this is a set. This is a set in what form? So I discussed in my first video, roster or tabular form. Now in Venn diagram form, this will be in a circle. All the four will be inside a circle, and outside the circle these, which are the 6. So these are 4 digits. There will be 6 digits outside. So that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 3, 7, 8, 9, 5. So these numbers are not inside the set A. So but they are in the universal set. So this is the representation of these two sets. The rectangle represents universal set. So in Venn diagram, always draw first the rectangle, which will mean universal set. Now all set, every set, or you can say all sets have a universal set. All right. So first of all, you draw the universal set rectangle, and inside that, 1 circle, 2 circle, 3 circle. So as many as subsets are there. All right. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all these 10 digits are there, and these 4 digits are inside the set A. So A is a subset of, so this is A, this is U, this is A. So obviously A is a subset of U. A is a subset of U. All right. So this is the way how to draw Venn diagram. Okay. Okay. Now suppose these two. Now let us see again these two sets. Say Now see another diagram, another pair of sets. Suppose E equal to one set, and then E equal to, then that is set 0 to 9, that is x is a digit. So this is what form? The same set of digits I have written in what form? Builder form. So x such that x is a digit. Now suppose this one. Say A has 1, 2, 3, and then another set B, say 9, 8, 7. Okay. Now there are two subsets. So A is a subset of U, obviously, containing 1, 2, 3. Again, B is a subset of U containing 7, 8, 9. The order is not important, isn't it? Now, how to draw Venn diagram for this one? So again, you draw a rectangle. Draw a rectangle. So this will be U. All right. Now inside U there are two sets, A and B. Now if you notice, A and B have no elements common. So they are completely separate. So this will be A and this will be B. So this is A and this is B. And the whole rectangle is U. Now A has what? 1, 2, 3. So suppose this is 1, 2, 3. And B has 7, 8, 9. So 7, 8, and 9. All right. So these are the two sets. No doubt A is a subset of B. A is a subset of U. B is a subset of U. Both are subsets of U. But they are completely different. This type of different sets are called disjoint sets. So these are what sets? Disjoint sets. Disjoint. So A and B are disjoint sets. So there are three sets. One is universal set and other two are subsets of U. But they have no elements common. So that is why they are called disjoint sets. So what are disjoint sets if you want to define? So two sets are said to be disjoint if they have no element common. But if they have at least one element common, they are called intersecting set. Okay. So these two are disjoint sets, and this is the Venn diagram for these three sets. So U is a universal set, then A, that circle contains 1, 2, 3, and B, the circle contains 7, 8, 9. Okay. Now let us see intersecting sets. So Venn diagram of intersecting sets. All right. Yeah, suppose U, this is a universal set. Then suppose A is this set. 1, 2, 3, 4. And suppose B is the set 4, 5, 6. Okay. So again, these two are subsets of U. So A is a subset of U, B is a subset of U. Now what will be the Venn diagram for these three? So again, that rectangle, which means the universal set U. Then these two are intersecting sets. Why they are called intersecting sets? Because they have at least one element common. Then what is the definition of intersecting sets? The two sets are said to be intersecting if they have at least one element common. At least one element common. So the intersecting sets will be drawn this way. So these two circles are intersecting. These two circles are not intersecting. So they represent disjoint sets. Now these two circles are intersecting. So they represent intersecting sets. So this is A and this is B. All right. Now what is the common element? 4. So 4 will be in here. Because you see, these two circles have which area common? This area common. So which is a common area? This one. This is a common area, isn't it? This is a common area between the two sets. So this common area will include this 4, which is a common element. Okay. So 4 is here. 4 is here. And then A has what? 1, 2, 3, 4. So 4 is here. So 1, 2, 3. So A includes 1, 2, 3, 4. And B includes 4, 5, 6. So 4, 5, and 6. So the B set contains 4, 5, 6, and A set contains 1, 2, 3, 4, and 4 is the common element. Therefore, these two sets are intersecting sets, and this is the Venn diagram. All right. So this is a Venn diagram of intersecting sets. This is a Venn diagram of disjoint sets. Is it clear? Then still there is a third kind. Still there is a third kind. Suppose this one. U is this. Now A is 0, 1, 2, 3, 4. And B is 1, 2, 3. Okay. Now consider these three sets. This is an universal set. Now A is 0, 1, 2, 3, 4 and B 1, 2, 3. Now see, B is a subset of A. So if you notice, B is a subset of A. Now obviously each of them is a subset of U. A is a subset of U, B is a subset of U. But between A and B, what is the relation? B is a subset of A. Why? You see, these 1, 2, 3 are present here. These three elements are included in A, therefore B is a subset of A. Now what will be the Venn diagram for this? All right. Now these three sets, again that rectangle, so that rectangle will represent U. All right. Then you see this is the diagram. This. So this is A. A will be the larger circle and B will be the smaller circle. So this is A. This one is A and this one is B. So B is a subset of A. That means all the elements of B are included in A. So the whole circle B will be included inside A. Now B has which one? 1, 2, 3. So B contains 1, 2, 3. So B contains three elements, 1, 2, 3. Okay, 1, 2, 3. And A has what? 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. So this is the diagram, Venn diagram of these three sets. U is a universal set, and then A has 0, 1, 2, 3, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, that is included in A, and B includes what? 1, 2, 3, 1, 2, 3. So B is completely inside A. That means B is a subset of A. All right. So these are different sets, and for which you are supposed to know how to draw the Venn diagrams. Okay. All right. Now, yes. Now we'll discuss operation of sets. Operation of sets. Now, operation of numbers, you know, addition, subtraction, multiplication, division. Those are various operations of numbers. Now we'll see operation of sets. Okay. Operations of sets or on sets. Operations on sets. The first one is union. Union of sets. Union. All right. Now suppose A is this set. A is a set, suppose 1, 2, 3, 4. All right. Then B is a set, suppose 5 and 6. Now adding A and B. So how to add A and B? A union B. All right. That this symbol union. Union means addition. This is called union. So how will you read it? A union B. Now that means we have to add A and B. That means we have to add all the elements of A and B together inside one set. So we'll put all the elements of A and B together inside one set. So A union B is a set. A union B is a set containing all these letters 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. So this set is the union of A and B. So A union B is this set which contains all the elements of A and B. All right. Okay, so it is simply like addition. All right. Now these two are disjoint sets. If you notice, they are disjoint sets. They have nothing in common. All right. Now suppose they are intersecting sets. Now consider these two intersecting sets. Suppose A is this and B is suppose 3, 4, 5, 6, 7. Suppose this one. Now these two are intersecting sets because they have 3 and 4 common. Now what will be the A union B? What will be the set A union B? Now the set A union B will be these elements and these elements together but without repetition, because when you write elements in a set you are not supposed to repeat. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6 and 7. Now 3 and 4, they are present in both, but we will not repeat. We will write 3 and 4 only once. So therefore, how many elements will be there? 1, 2, 3, 4, 5, 6, 7. 7 elements will be there because 3 and 4 present in both, but they will not be repeated. So these two are intersecting sets, and their union will contain these elements. Okay. Yes. Then still this example. Suppose now A is, suppose this one, then there is another, suppose set C. So C has suppose 4, 5 and 7. Okay. Now consider this set. Now suppose you want to write B union C. B union C. Now B union C, you see. Now B union C, C is a subset of B. 4, 5, 6 are present here. So C is a subset of B, isn't it? C is a subset of B. C is a subset of B. So what will be B union C? All the elements of B and C, but without repetition. Without repetition. So how many elements will be there? Which elements will be there? 3, 6, only 3 and 6. Only 3 and 6. B union C will be, sorry, 3, 4, 5, 6, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Yes, 3, 4, 5, 6, 7. 3, 4, 5, 6 and 7. Yes. So B union C, these two we are adding. We are adding these two, B union C. That means all the elements of B and C together, but without repetition. 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Because 4, 5, 7 present in both, but no repetition. So this is the set. All right, 3, 4, 5, 6, 7. B union C. Okay. So this is how you can add. You can add means you can put together elements of 2 or more sets together using this kind of rule. All right. Now generally the union is represented like this. So A union B is a set of X such that X belongs to A and also X belongs to B, and also X belongs to B. X belongs to B. Or, yes. So this is the general expression of A union B. General expression of A union B. So A union B, this is a general way of writing. A union B is a set of X such that X belongs to A or X belongs to B. Now if you see this set, so it contains the element which belongs to B or belongs to C. Now see, 3 belongs to B, 3 belongs to C, or X may belong to both. You may write X belongs to A or X belongs to B or X belongs to both, but that need not be written. So in general expression we write only this way. So A union B is a set of X such that X belongs to A or belongs to A. That means X should belong to A or B, or it may belong to both. All right. Okay, so this is a general expression of what? A union of 2 sets. So this is about union. Now come to next operation. There are some, before we go to the next operation, which is intersection, let me show you the properties. the properties of union. So there are some properties of union, right? The properties of union. Properties of union of sets. Properties of union of sets. Okay. Now A union B and B union A, the same thing. Now, A union B is a set containing the elements of A and B. B union A is a set containing the elements of B and A. So it means the same thing. So these two sets are equal. This is the commutative property. Commutative property. For example, x plus y, a plus b equal to b plus a. You have learnt in maths, isn't it? A plus b equal to b plus a. So what is the name of this property? Commutative property of addition. That way there is commutative property of multiplication. So this is the commutative property of union. This is a commutative property of union. So A union B equal to B union A. It is like A plus B equal to B plus A. So this is a commutative property of union. All right. Then A union B union C. So three sets are involved. So this is same as A union B union C. So in addition also you have this kind of property which is called associative property. A plus B plus C, B plus C within bracket, that is equal to A plus B within bracket plus C. So A plus B plus C, A plus B within bracket, that is equal to A plus B plus C, B plus C within bracket. So this is the associative property of addition. Similarly, you see A union B union C, here A and B are associated, equal to A union B union C, here B and C are associated. So this is called associative property of union. This is the associative property of addition. This is the associative property of union. A union B within bracket, here B union C within bracket. Union C, C is out, here A is out. Okay. All right. Then number 3, A union null set. A union null set will be obviously A. Suppose A contains 1, 2, 3. Null set contains nothing. So what is the set A 1, 2, 3 and none set? That is A only. So A union null set is A. All right. That means suppose you want an example. Say this set 1, 2, 3. This is a union null set. Null set means empty set. So this is suppose A union null set. Null set is empty set. So what is the union? The set containing all the elements of this and this. That means 1, 2, 3. So isn't it simply A, the first set? So A union null set is simply A, isn't it? So this one. Okay. Then A union A, it will be A. A union A. Suppose A is 1, 2, 3. A is 1, 2, 3. So 1, 2, 3 union 1, 2, 3. So same 1, 2, 3 without repetition, isn't it? Then last of all, A union universal set. Obviously it is a universal set. A union universal set. Suppose A is a set of digits 0, 1, 2, 3, 4, 5. And universal set is the digit of is a set of all the digits. So what will be the union? The universal set, obviously, isn't it? So A union universal is the universal set. So these are the 5 properties of what? Union of sets. So here you see 2 properties, that is commutative and associative. These two are similar to those properties of numbers. Okay. All right. Now we'll go to intersection of sets. So first we did union of sets. Now we'll go to intersection of sets. Intersection of sets. So the second operation. So we are discussing operation on sets or operation of sets. So now the next operation will be intersection. Intersection of sets. All right. Now these chapters said is included in CBSE syllabus, it is included for class 10. But in some other boards, it is included in 10. This is included, CBSE, this set is included in class 11. But in some other board, it is included in class 10. And for SEBA, it is included in, I think, advanced maths. Okay. All right. Now, the next operation is intersection. Intersection of sets. Intersection of sets. Okay. Now, let us see this one. So, suppose A is this one. 1, 2, 3, 4. Right? And B is suppose 2, 4, 6, 9. Then A intersection B. This is a symbol of intersection. So this was a symbol of union. So this was a symbol of union. And the inverse, this is a symbol of intersection. Symbol of union, symbol of intersection. So A intersection B is a set containing the common elements. Which are the common elements? 2 and 4. 2 and 4. So this. So A intersection B is a set of common elements of A and B. That means the elements which are present in both. So A intersection B is the set. How will you define? A intersection B is the set containing the common elements of A and B. That means the elements which are present in both, not only A or B, containing in both. Therefore, what will be a common expression? What will be a general expression of intersection? So A intersection B is X such that X belongs to A and X belongs to B. In case of union, we wrote X belongs to A or X belongs to B, or. But here X belongs to A and X belongs to B. That means X must belong to both A and B, not either A or B, both. In case of union, it is either A or B. But in case of intersection, X must belong to both and. So this is the general expression of, what? Intersection. So A intersection B is a set of X such that X belongs to A and also X belongs to B. All right? X belongs to A and also X belongs to B. Okay. Now, yes. Now, what will be the Venn diagram of this one? So the Venn diagram intersection. So this is the universal set. Now here we have not indicated the universal set, but every set has a universal set. Therefore, we must write here U. So A and B, they are intersecting. So this is A, this is B. This is A, this is B. All right, intersecting. What are the two elements intersecting? 2 and 4. So this 2 and 4. And A contains 1, 2, 3, 4. So 1, 2, 3, 4. And B contains 2, 4, 6, 9. 2, 4, 6, 9. All right. So this is the intersection. Okay. All right. Now suppose you are asked to shade. Now in the exam you may get like this: shade the set, shade, that means put shading, shade the set to show intersection of A and B. Now intersection of A and B, A intersection B, if you want to show by shading, then you have to shade this part. You see, you have to shade this part. Suppose in the exam you get the question, show by shading A intersection B, then you have to shade this part because this is a common region of A and B. Is it clear? Okay. Then suppose AB, suppose there is a set C. Now C is suppose 4 and 9. 4 and 9. Okay. Now How will you show B intersection C? B intersection C. B intersection C. So this time not A, only B and C. So this is U and then B and C. Compare B and C. Now C is a subset of B. You see this 4 and 9 they are present here. So C is a subset of B. That means C will be completely inside B. So C will be completely inside B. So this one. So this is B and this one is C. The inner circle is C, outer circle is B. C is completely inside B. That means C is a subset of B. So compare these two sets. So C contains 4, 9 and 4, 9 is here. Alright. So C is a subset of B. So C will be completely inside B when you draw the Venn diagram. Alright. And suppose you have to show by shading. Suppose the question is show B intersection C by shading. Therefore, what is the intersection? B intersection C. So B intersection C will be which set? Let us write the set first. B intersection C will be which set? B intersection will be 4, 9, isn't it? B intersection C, that means common elements of B and C. Now what are the common elements of B and C? Obviously 4 and 9, isn't it? So this set is B intersection C. So suppose you have been asked to show by shading, then you will shade this part, isn't it? So B intersection C is 4, 9. Now 4, 9 is C only. So B intersection C will be 4, 9. 4, 9 is C. So this C you will shade. Suppose the question is show B intersection C by shading. So this is the shaded part. All right. Okay, then now suppose you have three sets intersecting. Suppose you have three sets intersecting. Suppose A is this 1, 2, 3, 4, all right, and B is suppose 3, 4, 5 and 6, and C is suppose 4, 8, 9. Okay, all right. Now A intersection B, A intersection B intersection C. Now suppose you have to show this one, A intersection B intersection C will be what? Now A intersection B intersection C, first of all let us see this part, A intersection B. Now A intersection B is which set? A intersection B is which set? 3 and 4. You see, to find A intersection B intersection C, that means the common elements of A, B and C. First of all let us find using associative property A intersection B. So A intersection B which? A intersection B will be the common elements what? 3 and 4. Yes. Now therefore this intersection C. Now C is what? 4, 8, 9. 4, 8, 9. You see? A intersection B intersection C. First of all find out A intersection B. A intersection B is which set? The set containing 3 and 4. Then intersection C. C is 4, 8, 9. Now what is the intersection of these two sets? Say these two sets, what is the common? What is the common? 4. So you see this 4. So this is the answer. This is the answer of what? A intersection B intersection C. So A intersection B intersection C, we use associative property. First of all, we found this part. You can also first find B intersection C, putting within bracket. You will get the same answer. So first we did A intersection B, and then we did intersection C, then we got the answer 4. Okay. Now, what will be the Venn diagram? What will be the Venn diagram? Let us see. Now this is U. Now these three sets have one element common. All right. Now first of all these two sets, suppose A and B, and then this is the third set. So this is A, this is B, this is C. All right. Now between these three circles, which is the common area? This is the common area, you see. So I am shading this part common area. You see, this is a common area. Between these three circles, which is a common area, this is a common area. Now this 4 is present here. So this area contains 4. Okay. Then other elements. So 4 is there. So 1, 2, 3. A contains 1, 2, 3. A contains 1, 2, 3. So 1, 2, 3. So 1, 2, 3, 4. A contains 1, 2, 3, 4. 1, 2, 3, 4. B contains 3, 4, 5, 6. B contains 3 is here. 3 is here. 3 will be there. 3, 4, 3, 4. 4 is there. 5, 6. Yes. See, if you want to put the elements, A contains 1, 2, 3, 4. 1, 2, 3, and here 4. B contains 3, 4, 5, 6. 3, 4, 5, 6. This is B. And C contains 4, 8, 9. This is 4 here, 8, 9. So if you want to put the elements like this. So A contains 1, 2, 3, 4, 1, 2, 3, 4. Now 3 and 4 are common elements between A and B. And between A and C, what is the common element? 4. Between B and C, common element is 4. Now among all the 3, what is the common element? 4. So that is the A intersection B intersection C. This is a Venn diagram to represent what? A intersection B intersection C. Suppose in the question you are asked, show by shading A intersection B intersection C. Then this is the shaded part. That is the answer. All right. Okay. Now see the properties of intersection of set. So just I gave you 5 properties of union of sets. Now let us see the properties of intersection of sets. Properties of intersection of sets. So first property is this one. First property is commutative. That is A intersection B is equal to B intersection A. So this is what property? Commutative property. Commutative property of intersection. So A intersection B and B intersection A, they mean the same set. So that is commutative property. It is like A plus B, B plus A, that already we discussed. Now the second property is the associative. Just now we did A intersection B intersection C. So that is equal to A intersection B within bracket, then intersection C, and that is equal to A intersection B intersection C. So you see this one. If you have to find the intersection of 3 sets, so first you put together the first 2 within bracket, A intersection B, then intersection C. Or next you can put these 2 together, second and third together, this one. So A intersection B within bracket, then intersection C, or A intersection B intersection C within bracket. So this is what property? Associative property. Associative property. Associative property of intersection. This is the commutative property of intersection, and this is the associative property of intersection. Okay, here associating A and B, and here associating B and C. Associative property of intersection of sets. Then the third property, A intersection null set. A intersection null set is null set. That means suppose A is 1, 2, 3. A set is 1, 2, 3, and null set is no element. So what is a common element? Nothing. So null set. So A intersection null set is null set. Then A intersection A. A intersection A. A intersection will be A only. Suppose A is a set containing 1, 2, 3. A is a set containing 1, 2, 3. So what is a common element? 1, 2, 3 only, therefore A only. So these are the 4 properties of what? Intersection of, there is another property which is distributive property. That union has only commutative and associative, no distributive. But in case of intersection, we have a distributive property. We have a distributive property, this one. So distributive property is this one. A intersection B, A intersection B, A union B intersection C. A intersection B union C. Yes, this is a combination of intersection and union, you see. So this is called distributive property of intersection and union, because here you see both are there. This is intersection, this is union. A intersection B union C. All right. So this will be equal to A intersection B union A intersection C. A intersection C. So you see it is like this. Suppose x into y plus z. What is x into y plus z? Isn't it xy plus xz? So x into y plus z, xy plus xz. It is like A into B plus C. So A into B plus A into C. So you see. So A intersection B union C. A intersection B union C equal to what? A intersection B union A intersection C. So this is called distributive property. This is distributive property of sets. This distributive property of set. Distributive property of set. Distributive property of set. All right. So it is like this one. X into y plus z equal to xy plus xz. So A intersection B union C equal to A intersection B, then union A intersection C. Now what will be the Venn diagram for this? So let us see the Venn diagram for this one. So Venn diagram for this distributive law, distributive property. Okay. So consider this universal set U. Now it has three sets. It has three sets A, B, and C. Now they are intersecting. So this is A, this is B, and this is C. So this is A, this is B, and this is C. All right. Now, first of all, A intersection B. A intersection B, which region? A intersection B. This is A and this is B. A intersection B is which region? This region. So first of all, let us see this part. So we want to find out A intersection B union C. So first of all, we must find, we are going to find A intersection B. Now A intersection B will be which region? This is A, this is B. Which is a common region? This is a common region. So that is A intersection B. Now A intersection C. A intersection C will be which region? A intersection C. A intersection C will be this region. A intersection C will be this region. So A intersection B is this region. You see, I am drawing like this. This is a region for A intersection B. A intersection B is this region. Then A intersection C is this region. A and C, which region? This region. This is A intersection B and this is A intersection C. Now A intersection B and A intersection union, that means together. Now together these two regions will be this whole region. This whole region. So you see, the first A intersection B is this region. A intersection B is this region. Then A intersection C is this region. A intersection is this region. Therefore, their union will be what? The whole region. See, whole region, this one. So this shaded part represents A intersection B union C. So suppose in the exam you are asked to represent by Venn diagram A intersection B union C. A intersection B union C. So that will be this region. This is the answer. So this shaded portion represents what? A intersection B union C. All right. Okay, then last one for today. difference, last operation. So we did union, we did intersection, and last operation is difference. Last operation today, difference. Okay, difference of sets, difference of two sets. So this is a third property, third operation, difference. Difference of sets. Obviously, difference of two sets. Difference of two sets. All right. Now consider this set. A is suppose 1, 2, 3, 4, 5. And B is suppose 3, 4, 5, 6, 7. Okay. Now, A difference B. You can read it as A minus B. You can read it as A minus B, or you can read it as A difference B. This is how it reads, A difference B or A minus B. Now, A difference B is a set, yes, in builder forms. This is a general expression. It is a set of X such that X belongs to A, X belongs to the first set, but X does not belong to the second set. This is a general expression. General expression for A minus B or A difference B. A difference B or A minus B is a set containing the elements of A which are not present in B. So it is a set of X such that X belongs to A, first set. X is an element of the first set, but X is not an element of the second set. X does not belong to B. Now using this general frequency, let us find out A minus B. A minus B. A minus B will be what? Yes. See? Elements belonging to A. Elements belonging to A but not belonging to B. Elements belonging to A but not belonging to B. Which elements belong to A but not belong to B? Yes. 1. 1, 2, 1, 2. 1 is not there, 2 is not there, and 3 is not. 3 is there, 4 is there, 5 is there. Yes. So only 1 and 2. Only 1 and 2. All right. So A minus B or A difference B is a set containing elements of B not present in B. Elements of A but not present in B. Now which elements are present in A but not in B? 1 not in B, 2 not in B, 3, 4, 5. Yes, only 1 and 2. Then what will be B minus A? What will be B minus A or B difference A? This is A minus B. Now what will be B minus A? That means elements belonging to B but not belonging to A. Elements present in B but not present in A. Now which are the elements present in B but not in A? 3 is there, 4 is there, 5, 6, 7. See, 5, 6, 7. So A minus B is a set of elements belonging to A and not belonging to B. Belonging to A, not belonging to B, that is 1 and 2. Then B minus A is a set containing elements of B but not present in B but absent in A. Present in B, absent in A. That means what? 5, 6, 7. 5, 6, 7, isn't it? 5, 6, 7 not here. 3, 4, yes. So this is the thing. This is difference of set or this. Now suppose you want to represent by Venn diagram. So you want to represent by suppose Venn diagram. All right. Now what will be a Venn diagram for this? You see, what will be Venn diagram for A minus B and B minus C? Now see, this is a Venn diagram for A minus B. This is a universal set. Now A and B, obviously, now for these will be all always intersecting sets. Okay. So this is A, this is B. So this is A, this is B. Now common element, which one? Which are the common elements? 3, 4, 5. 3, 4, 5. No? Yes, 3, 4, 5 common elements. So here there will be 3, 4, and 5. This common region will contain 3, 4, and 5. So A will be 1, 2, 3, 4, 5. Then this will be 3, 4, 5, 3, 4, 5, 6, 7, 6, 7. So A 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and B 3, 4, 5, 6, 7. Right. Now A minus B is what? 1, 2. Yes, this reason. This is the region representing, this is a shaded region which represents what? A minus. So this region represents what? A minus B. So A minus B is this part, this shaded part, completely outside B, this shaded part, A minus B. That means the elements present in A but not present in B, therefore completely outside B, it should be completely outside B, right? So this is A minus B. Then what will be B minus A? 5, 6, 7, this part. So B minus A will be this part. See? So B minus A will be completely outside A, because elements present in only B but not in A, therefore this part. So this part is what? This part. This part is what? B minus A. And this part is what? This part is A minus B. Then what is this part? This is a common part. So this part is what? A intersection B. See. The middle portion, this part. So this part, this middle portion is what? This middle portion is obviously A intersection B. Already we discussed A intersection B. So the middle portion is A intersection B. And this left portion. So this left portion is what? A minus B. And this right portion. This right portion is what? B minus C. So in the same diagram, you can represent these three, A minus B, B minus A, and then A intersection B. This way. I mean, in exam, you have to shade separately. All right. So today I discuss up to here. So now it will continue. You see, there are other things to explain in this chapter of set. So this is the third video. Then I think 2 more videos will complete the chapter. Okay. All right, done for today. Thank you.